I've started recording, and I'm going to share my desktop. Okay, everybody should be able to see my desktop now. Can you guys see my desktop?
Yep.
Okay. So just to let you know, today, this morning, I put up 2 videos on YouTube, and I sent around a link. I did an announcement for a link, and it talks about how to do the fixed length and variable length challenges. So that way we can talk about them, but we don't necessarily have to go through them, and we'll have time to get to both file handling and regular expressions tonight. But those videos are up in there, a walkthrough of, like I've done other walkthroughs for the challenges. Okay?
Sounds good.
But if you have any particular questions, stop, of course, and we can talk about them, okay?
Sounds like a plan to me.
All right, cool. So basically, what we've done up till now in the class is everything has been about in-memory data. All of our data structures have been about in-memory data. Everything has been about in-memory data. But what we really, that's not practical. It's just not practical from a processing standpoint. You can't keep all data in a computer memory. You need to be able to write things to files, read and write from files. So this section moves us from just having normal data structures kept in memory to being able to store things in files. You know, files keep things like, you know, an MP3 file is a music file. You know, a Word document is a file that has a specific format that the program Microsoft Word understands. So that's what we're doing now. We're laying the foundations so that when you go further on in Python or when you go further on in any other language, you will understand about how to read and write data to a disk on a computer. So this is just the experiments go here section. Okay, every file has a name. And with that name goes a naming convention. A file name is the entire path of where that file sits on a disk. So if I have a My Documents folder on, let's say, a PC, My Documents sits under, you know, maybe I have C: My Documents. The C: is the root, and it tells us what drive it's on. And then My Documents is a folder name, and then I have the name of a file. So if I looked at this MS-DOS path right here, I have C:. C: says I have a physical piece of media that is given a name, and that name is C. And then I have a nomenclature. I have colon, which always comes after, on Windows, always comes after the drive. And then I have slash, which says, take me down one step, either to a file or to a folder. Then I might have a folder name and then a file name. So that's the naming convention on Windows, and that's the entire, for filename.txt. This is really the entire fully qualified name, and that's important to remember because when you're programming, you have to have fully qualified names. Your program, you have to tell your program from the root on down where you get that file, because there could be 2 filename.txt on your computer. One may be in folder 1, and one may be in something called folder 2. So you need to be able to give it the fully qualified path. And fully qualified paths look different on different systems. MS-DOS is very standard. Most people know it. Those people who play, like me, who play in the Linux world, they know that it's the other type of slash from the Windows slash, and then it's a folder name and then the file name. And it could be any number of folders. The Win network path is a little different. A URL for the World Wide Web is a little different, but this is still a file. And then an FTP URL. Again, still a file, different protocol. So that's just to introduce you to the concept of just because it's called filename.txt doesn't mean that's the only part of the name. The name is the fuller, fully qualified path, which includes the drive and any folders under which that file sits. So file descriptors. Every file has a file descriptor. The operating system hands you that file descriptor. And a file descriptor is how the operating system sees that file. Now, we don't have to be able to read or write a file descriptor. We just have to know how to use a file descriptor if we need to use a file descriptor. And what it basically is, depending on the file system, is that it's just a unique number. That's all it is. So when you open a file, as part of opening that file, you get a descriptor. And the descriptor right here is Python calls it file no, so you use the file no function. But if we go through this code here on the left, first, let's look at lines 3 through 5. We have something called Path A, Path B, and Path C. Path A is a fully qualified path or URL to the file parrot.txt. Now, this fully qualified path is different than you will see on many different operating systems because it's just giving you a relative path for Codio. So you won't see a C colon or a /temp or something along those lines. This says, relative to where I am, go to the folder context, then go to the folder text files, which is defined under context, and then get me the file parrot.txt. Path B is the same thing, except for the file empty.txt, and Path C is the same thing, except for the file cheese.txt. What do I do when I have a file name? Because this is just a string. All Path A is, it just contains a string. It's inside quotes, there's nothing special, it's a string. The open function in Python says, okay, I am about to go out and try and access file on disk. So in line 7, what we see is I have a variable named file A. It's just a variable, and I'm setting it equal to the result of the open function for Path A for reading, and that's what the R is for, and we'll talk a little bit more about that in a minute. This open function is given to us by sys. Okay? So we always import sys. Well, this is we're importing sys, and we get this open function for free. What open does is it says, I'm going to go out and I'm going to access a file on disk, and I'm going to make those contents of that file available to a program. And so that's what it does. And if you get an exception here, it's because the file usually doesn't exist. So what I have done is I have set basically not the whole file, not the contents of the file, just a reference to the file into the variable named file A. And on line 8, I do it for the variable named for file B. The variable named file B becomes a reference to the information on disk for Path B. And then if I want to get a file descriptor, I can. I just say FD1 is file A.filename and file b.file now. And you will see if you print them out that they have different file descriptors. The numbers are different. Now here's something I'm going to sound like a broken record on. File a.close is what line 16 does is it says, I know I've opened the file for reading, or for writing, it doesn't matter. But now I'm going to tell you that I'm done with it. And you have to do this because you have to release the file descriptor if you want another program to be able to get to that file. And because most operating systems have limited numbers of file descriptors, and you don't want to use them all up in your program because then you can't open any files. So line 16 is very important. For every open you have in a program, you need to have a matching close. And I'll say that again. For every open you have in a program, you need to have a matching close. And then here we just have another thing for a file descriptor on lines 19, 20, and 21. So if I run the code, what happens is I get file descriptor for file A is 3, file descriptor for B is 4, closed file descriptor A, and then they give you file descriptor C is 3. And because I closed A, it gave me 3. It recycled the number. Some operating systems do that, and some operating systems don't. So don't assume that every file don't assume how the file descriptors work on a given operating system. Go read up on the operating system. We really won't be using file descriptors. That is simply here so that you can get used to the concept that a file has this thing called a descriptor. Now here what becomes really important. Opening a file. To access a file from disk, we have to open it. That's the only way to do it. It's the only way in any programming language I've worked in to get data from a file into my program. I have to open it, I have to read it, and then eventually I have to close it. And if I want to put information from my program onto disk, I have to open it, I have to write it, and I have to close it. So each of those are 3 things you have to do. So for opening a file, you have to open it, in this case for reading, and here they're just doing file descriptors, and then they're closing it. Closing a file is extremely important. We've already run the sample code, and we've already talked about closing a file. For every open, you have to have a matching close. Okay, so text files. There are lots of different kinds of files out there, but basically there's text files and there's binary files. A text file is human readable. I can open it up and I can read that file and probably make some amount of sense of it. Binary file is a file that is in binary and I can't read it. If I open it up, it's got lots of gobbledygook lines in it and there's nothing there that I can read. So that's just basically the difference. Is human readable or not human readable? If they're human readable, there's different types of encodings. And this is just something for you to note in case you're ever dealing with different kinds of encodings for file. There's ASCII, which is common, UTF-8, which is common. So in terms of what we're going to be doing in this class, it's important to note that there are different types of encodings and where they came from, but we're not going to be using the different types of encodings. Reading a text file. I have to open a file with some intent in mind. I can open it for reading, I can open it for writing, or I can open it for appending. If you're only going to get information from the file into the program, so I've opened a file and I'm going to bring data in, then you have to open it for writing. And if you look at this, look at line 5, what you will see is I'm using the open command, the open function for file path. File path is defined on line 2. And I've got this R in quotes here. That R says I'm opening whatever is in file path variable for reading, and I'm giving myself a reference to it, to file 1. Well, what can I do with that reference? What I can really do with that reference is I can read the data in. So whatever that data is in that file, I can read it in and print it out. Very simple, very straightforward. But I'm going to do something here that they didn't do. File1.close. Gotta always remember to close that file. So if we run the sample, the parrot is no more. So basically what it did is it opened the file, it read the information from the file, and we printed it out, and then I closed the file because it irritates me that this particular example doesn't have a close. Okay, so here's a code challenge. We're going to read the text file. All right, so we're given a file path P and a string S on the command line. Output the number of times the string S appears in file P. So let's first go back here. If I have a file and I want to open a file for reading, I do what's on line 5. Okay? So in this case, I'm going to say file 1. I'm going to open path P for reading, and then I have some S. So what I want to do is I want to find all occurrence, the number of times the string S appears in the file P. So I'm going to say S dot, I think it's fine. Now it's just imports this. Wait a minute. Sorry, first I have to read the data in. My apologies. Sorry. So I'm going to read the data in. Let me do this. Let me keep myself. Open the file P for reading. And then I'm going to read in the file data. And then I'm going to number of occurrences of S in the file data. And then I'm going to close the file. That's what I'm going to do. So I've already got file 1 equals open P. So let's go back here and let's say read the file data. Well, we've got this here, data equals file1.read, and we print the data. So I'm just going to copy those because it makes it easier and quicker than typing. Okay, so I'm going to do this. So I read it and print it, but in the middle of that, I have to find the occurrences of S in data, in the file data. So I'm going to say data dot, let me see something here. This will be good. This is just basically an example so that you can understand when you don't remember off the top of your head exactly how to do something in Python, which happens to me sometimes. You can go out and search and find the right answer. Find the number of occurrences of a substring in a string. Stack Overflow is a very good site. And hold on, let me make this Python. Okay, so we have count. Cool. We have this string.count function. Let's see if that's the best answer. That's probably the best answer. Let's see what happens when we use string.count. Data.count. Okay, and then we're going to print F, and we're going to print num F, and then we're going to say file1 dot close. Let's see what happens when I run it. Okay, it checked out. So what we did again to review is we opened the file for reading. We read in all of the data. In this case, we got a count of the number of times F occurred in the data. We printed it out, and we closed the file. So now we're going to write a text file. It says you can write the contents of a text file, and that's pretty easy. It's the same process you took before, except for instead of opening a file for reading, you're opening a file for writing. So you still have a file path, and in this case, I have some text that I'm going to put in that file. Here, I open the file path for writing. That's what the W in single quotes means. I'm going to write the text to my file, and then I'm going to close it. And then I can double check that everything was right. I can open the file for reading, I can read it in, I can close it, and then I want to write something else. So I can open the file again, I can write something, I can close it, I can open it and close it. So this just shows that you can open and close it a lot. The important part here for writing is this W in single quotes. I'm opening a file for writing, which means I'm going to alter data sitting on the disk. So if we want to run the write sample, that's basically what it does. Because the first time I wrote it out, I wrote a newt, and so there, and then I opened it, printed out what I was reading in, closed it, opened it for writing, wrote something different to the file, and you'll notice that I got better and a newt. Each only happened once. So when we open it for writing, we clear out the whole file and all of its contents. So when we use that W, the file becomes blank, and anything that was there goes away. Okay, so here's our challenge to write a file. They say you're going to provide a file path called I, and a file output path called O, and a string S and a string T. If you want to read the contents of I, replacing each occurrence of S with T, and write the resulting information to O. You should replace 0, O, if it already exists. So that means we're going to open it for writing. So we're going to open file I for writing. Okay. And then, for reading, my bad. And then we're going to read contents of I. We're going to replace each S with T. We're going to, open file O for writing. We're going to write the data and we're going to close file I and file O. So let's start by reading in the file, the information, opening file I for reading. So I'm going to say file I equals open I, comma, reading. So I did a quote R for reading. Now I'm going to read the contents of I. I'm going to say input equals file I dot read. Okay? And then we'll do a replace. So let's do that. Python replace character in a string. So we're just going to use the replace function. Here is a nice little thing about how to use replace. So old and new. So what we have and what we want to replace. So here, my bad, I'm just going to say input dot replace FT. And then I'm going to open file O for writing. So file O is open O, comma, for writing. So I have a W there. And then I'm going to say file O dot write. And I'm going to write input. And then I'm going to close. I'm going to close file I. And I'm going to close file O. So let's see what happens. See if I made a mistake. Yep. Your program did not match the expected output. Your output, expected output. Okay. The parrot is no more. The NI is no more. I did an input dot replace. Did I do that right? Do some printing here. Print input. Print F. Print T. And now we're going to do print input. Let's see what happens. I know this is all going to be wrong. So, program failed for input. So, that's my input. So I want to replace parrot with NI. And so replace input. Okay, input. Oh, that's wrong. There we go. File I equals open I for writing. File I dot read. Sorry, I'm trying to figure out what I did wrong. All right, so I have print input. Input doesn't look right. Temp W1, temp O1. Why is that for input? Hold on. I wonder if your program output. Sorry. Hello. I won't spend too much dwelling on this if I can't get it really quick. I will might just need another variable. Let's check it and see. Sorry about that. I'm drawing a blank on this one tonight. So I open it for reading. I open I. Let's make sure. Read the contents of I, replacing each occurrence of S with T. And write the resulting information to file O. File O, open O, write. File O dot write replace. So the replace isn't working. That's the problem. Let me run this again. Input. Okay, so this is input. And this is replace. Ah, that's why. Okay, so my replacement worked. I think this may be one of the issues. There are a few times when Codio doesn't do things right. And I'm wondering if this is one of those. Let's see what happens when I run it again. All right, there we go. So this is what we had to do. First of all, I had to get rid of my extra input statements. And then I set the variable replace to what the output of replace was, and I wrote the file, and it was correct. My apologies for that taking just a moment. Okay, data format. So here's where things get kind of interesting. First of all, files have extensions, okay? An extension is a .txt, an MP3, a docx, all of that. They just tell us, they're a visual indicator of what the type of the file is. Is it a music file? Is it a Microsoft Office file? What kind of file is it? So that's a good visual indicator. But that's not, somebody can go and change the extension of a file very, very easily. They don't have to do anything. They can rename a .doc file to a .txt file very easily. So how do we tell what a file really is? Well, there are these things called magic numbers, and they're the first 2 bytes of most files, and or some number. And basically what they do is they tell what a file type is. So if you have a magic number for a GIF, it's 89. If you have a magic number for a Microsoft Office documents, they have their own numbers. And that's so that people can tell, the magic numbers can tell what the file type really is. So if somebody changed a file from .doc to .txt, Microsoft Office would automatically know that it's still a doc file. And then people wanted a different way, and sometimes a better way than magic numbers, and they came up with MIME types. MIME types were used for the internet, and they're another way of identifying files. So again, we're not going to use this in this class, but it is just something to introduce the concept. The real important part about file types is fixed length and variable length records. Okay, so fixed length records and variable length records are, well, let's start with fixed length records. fixed length records say I have, let's take for example, 80 characters. So in these 80 characters, I'm going to divide so many characters up for, let's say, first name, and then so many for last name, and then so many for birthday. So if record has to be the same, and no record can be greater than 80 characters. And that's what a fixed length record is. So if the text input is 1 through 5 for the first name and 6 through 15 for the last name, then it has to be that way for every record. No person's name, first name, can be greater than 5 characters. So fixed length records are very good for some purposes. A lot of fixed length data is like satellite data. They use very fixed, very standardized formats for what messages are coming through, and that works very well for them. They don't have to have variable length records. Their fixed length records are just fine. Other things, like a Microsoft Office document, they have to have variable length records for those binary files. Very simple. So fixed length records have a purpose, and variable length records in files have a purpose. Fixed length records are important because if you have extra spaces, it's a pain. Well, first of all, let's take a look at the example on the left. If you're taking it, the data in this example, if you look at line 3, you will see what looks like a standard fixed length record. We have some number of spaces. What is it? 1, 2, 3. 3 spaces plus a 3-space buffer. So I would guess that the first 6 characters are for the first part of the record, and then the next 6 characters are for the next part of the record. And however that works, I don't really know what Codio is talking about when it comes to the record length, but the important part is that you can divide this record up based on the fact that the length of each individual piece of data is 6 characters long. And that's what you always want to be able to do. If you know in a fixed length record that each individual portion of that record is 6 characters long, then you always know that the next 6 characters will give you a new chunk of data, because that's really what we're doing. We're chunking the data at this point. And that's the great thing about fixed length records. Fixed length records, when you're dealing with text processing, are extremely easy to process because the records are always the same length. Or you know that, I have 100 characters, and I'm always going to have 100 characters, and 100 characters is going to be one record. And then the next 100 characters is going to be the second record. So their processing in some ways is very easy. The only problem is that if you get extra data in there, especially extra spaces, it can be a little bit tricky. So they give us the strip function. The strip function just removes beginning and trailing spaces. And it's something to keep in mind when you're doing your fixed length records. Now, I have a YouTube video up for fixed length records. So I'm not going to go through this run right now because it's 9:45, and I want to get to regular expressions. Additionally, variable length records or delimited records are records where you can have some character. A lot of people know about comma-separated value files or CSV files. So you have some data and then a comma, and then data and then a comma, and then data and then a comma. CSV files are a great example of variable length records. My individual chunk of data can be any length, but I know that that chunk of data is a chunk because I have a character in between them, a known character. And in the example here, that known character is a pipe. And so every time I hit a pipe, I know that, wait a minute, I'm finished. I need to move on to the next piece of data. So in this case, I've got 100, 1,000, 1, 9,999, and 700 in my variable length. And you'll see here the difference between line 22 in this Podio example, and in the previous example, I think it was, what was it? And in the previous example, line 3 is that line 3 in this example has a lot of spaces. In the fixed length records, you get lots and lots of extra space. In the variable length records, you don't. There are not a lot of extra spaces. You simply have a single character. So you don't have to take up as much room. Variable length record-based files can be much smaller. And that's important when you're dealing with, just huge, massive databases. Because a database ultimately is a file on disk. There are wonderful programs. Oracle makes great programs around processing their files. SQLite does a great job, but they're all files on disk. And you don't want to be wasting your disk space on empty spaces. You just don't. So they're delimited. There are some interesting things you can do to read and write this delimited or variable length records. You can join a list together and it will print it out as a variable length record with a delimiter. This is a neat, handy little trick. Delimiter.joinList will print, in our case, A:B:C. You can also split things based on our delimiter. Here, the delimiter is a colon, and I can split a string that is delimited with those colons using the split function. Very handy. Now here we have this sample program with functions. We have getList from delimited pipe where we use the split function. We have getPipe delimited text from list where we use the join function. And we have print records which goes through and prints the different records. And again, when we go to this variable length records challenge, I have put a YouTube video up that walks through how to do this challenge because the variable length records and the fixed length record challenges can be a little bit difficult, and since we don't have a lot of time to go through them in this particular conference call, because we're going to go on to regular expressions, I wanted to give you guys a complete walkthrough. So that is, and then here's the final challenge. And the final challenge is just variable length records and it's given a pipe delimited file, F1, F2. You have name, pin, balance, and basically you want to, based on the fact that you're getting input in, so file 1 contains the name, the pin, and the balance. File 2 contains a command, an amount, an account number, and a pin. They want you to alter the contents that you read in from file 1 based on the commands in file 2. And I'm pretty sure this one is up on YouTube. If it's not, I will put one up. But once you can do the variable length record one, you shouldn't have really any problems doing the final challenge because it really is just another variable length record. These are 2 files which have variable length records, and you modify one by acting on the other. So as long as you can add or subtract, and this looks very much like your ATM example, that is just modified using a file. So that is file handling. Does anybody have any questions? Okay. Regular expressions. I like to call regular expressions in Python a language within a language. Okay. What regular expressions are regular expressions are a way of searching and replacing and finding things in strings. Because that's what regular expressions are. They're all about strings. If you have a large paragraph or a whole document, let's say you're working on a Word document and you need to do a find and replace. The most efficient way for Microsoft Word to do that find and replace is do a regular expression. And a regular expression, they're very quick, they're very easy, they have their own syntax, but they allow you to modify information in a string based on a pattern. And that's very handy because sometimes, let's say the pattern is a social security number. 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. I don't know what those first 3 numbers are. I don't know what those second 2 numbers are, and I don't know what those last 4 numbers are, but I can write a pattern that can go through a string and find all of the social security numbers because I have a pattern. It's repeatable. 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. And doing regular expressions will help me is how you would do that. That's how you would create that pattern. So basically here, what we're talking about is there's 2 different ways to do it. Well, first, let's start with line 1. Line 1 here is import RE. Now this is different for us. We're usually importing sys. Sys is where we get file open, where we get open and close and all the string functionality and the float function and the stir function and the int function. All of those things have come from sys. Here, we're going to do something by importing RE. RE is the regular expression module in Python. And to do regular expressions, you have to import it. So when you're looking at doing your challenge your project for regular expressions, make sure to import RE. And here, if we look online we just have a string. We just have a nice long string. So this string is, to search for regular expression, regular space expression, regular dash expression, or regular colon expression, or regular ant expression. They want you to write a regular expression that will find all occurrence of regular space expression, regular dash expression, regular colon expression, and regular and expression in the search string. And we know by reading this, we can look through this and say we have 1, 2, 3, 4, 5 occurrences that we are going to have to count. And then it says we want to substitute regular space expression for all of the other ways of regular expression. So if there's a dash, if there's a colon, if there's an and, we want to change it. So first, we're going to do a count. So what I want to do is I'm going to use something called a find all. And first of all, I'm going to write a pattern. And hold on. I'm sorry, my bad. I started way at the end of this. So we're going to go back to the beginning. So my apologies. Sorry. What are regular expressions? Well, regular expressions are a language within a language, as I said. To enable regular expressions, you import the RE module. Now, the language of regular expressions is pretty interesting. You have meta characters and regular characters. Meta characters, which are all these characters, actually mean something to Python regular expressions, other than just a star, other than just a dot. And here we have a reference to all the meta characters in Python. This is a quick list, kind of a cheat sheet, that tells you what the meta character means. The dot matches any character except a new line. The caret matches the start of a string. The dollar matches the end of a string. Star matches 0 or more occurrences. The plus matches 1 or more. And the question matches 1 or more. So these are all just what the meta characters mean and how to interpret them. Here, we have some examples. So we have pattern ABC, and we're going to have string A, string B, string C, string AB, BC, ABC, and XABC. And if we run the code, what we see is we're going to match pattern, and pattern is here. So we have the meta characters, bracket, open square bracket, and close square bracket. And what I want to do is I want to find anything that will match that pattern. So what we see is that an A match, because this says get me any of, okay, or any combination of. So A, B, and C are all in the set ABC. AB is in the set ABC, BC is in the set ABC, and ABC is in the set ABC. However, XABC is not in that set because there's no X in the pattern. So, and here's what you see is you create a match. So you'll have a pattern and the string you want to match the pattern to. You use the regular expression module, and in this case we're using the match function. And match comes back and says there was a match or there wasn't a match. So if there's a match, if there's not a match, RE will always return none. And if there is a match, then it will return something other than none. So that's what we're doing here. And the match function comes from the RE module. Let's talk a little bit about wildcards, because people use wildcards all the time in regular expressions. The star is a meta character that people use, and sometimes they misuse. It basically matches 0 or more repetitions of the characters directly preceding the star for as many repetitions as possible. So if my pattern is XY star, what is going to happen if I try and match it to an X, an XY, or an XYYYY? Let's run it and see what happens. Well, first of all, X matched. X matched because it's XY star. So it can be the X or the Y or both. So it matched X, it matched XY, and it matched XYYYYY because here's X and Y, and we can have as many repetitions of X of the Y as we need. So now we want to search repetitions. So basically, the curly braces, we want to have an exact number of repetitions. Star said get any number of repetitions. Well, the curly braces allow us to say an exact number of repetitions, and this can be important because maybe you only want to replace the first two Social Security numbers with XXX-XX-XXXX. So we use the curly braces, and in line 3 what we're saying is our pattern is going to be the character A exactly 3 times. So will it match AAAA, or 3 A's, or AAAB, or 2 A's, or A? Well, let's take a look and see what happens when we match. So here we got matches for A 4 times, A 3 times, A 3 times followed by a B, but it didn't match for 2 A's or for a single A. That's because 2 A's isn't 3, and we're telling it that we have to have 3. And a single A isn't 3, and we're telling that we have to have 3. So, regular expression searching. So here we are back at the regular expression search challenge. So what we want to do here is we want to basically find the number of occurrences for the word regular expression, and then for any regular expression that has a dash, colon, or an and, we want to replace it. So we're going to use the find all function, and we're going to use match. Actually, we don't have to do a replace it. We're going to use find all and match. So let's go back and take a look at our example. And so we need to create a pattern. And let's go back and take a look at our non-example and see what that pattern is. So we're told here they want to write a regular expression of regular space expression, regular dash, regular colon, or regular at. So we know that the first part of the pattern is regular, and the last part of the pattern is expression. So we know that the pattern is going to be some variation of regular and expression. Now, the things that differ here are space, dash, colon, and. So really what I want to do is I want any one of those. Any one will do. Tell me if I've got the right thing. So what I'm going to do is say space, dash, colon, or and. Okay, so that's my pattern. So now I'm going to use the find all to determine if there are any occurrences in the string. So let's just do this. Let's just do we're going to do the outcome of find all method to match 1. So we're going to say match 1 is re.find all string, which is going to be search string. Oh, sorry, pattern and then search string. Pattern, search string. And then just to see what I'm doing, I'm going to print match 1. I'm going to check it. Oh, it didn't give me enough. Okay, so that's not going to help me. So print to the console the pattern used to perform the match followed by the words match. Oh, if match 1 is not none. Okay, so let's do this. All right. So I'm going to say if match 1 is not none, then print pattern. Otherwise, print to the console the pattern used to perform the match followed by did not match. Pattern matched. And then I'm going to say else. And then they want us to print out did not match. Okay, let's see what happens. Okay, so here what you'll notice is we really didn't have to write that much code. We did this regular expression, and the important part of the regular expression is right here. Okay, we know that the beginning of it's always going to be regular for our purposes, and expression is going to be at the end for our purposes. But the real important part is what's in the middle here. What I've done is I said, give me a set of any one of these characters, space, dash, colon, or and tell me if the word regular space expression is there, or regular dash expression are there, or regular colon expression is there, or regular at expression is there. Now, this is kind of important because this goes to your, it goes to the project that you will do for regular expressions. And here's a replace. So great if you can find things. But what about if I wanted to replace things? Well, there is also a replace function in Python. The replace function, again, is given by RE. And this is going to allow us to search and replace. And so what we have here on the left is we have a pattern, we have a substitution value, and we have sentence. In my string, I have my val, my dash val. Can everyone hear me? Hope so.
Yep, we can hear you.
Okay. So then we're going to replace the substitution is my. Sorry about that. I don't know what pre-conference call is doing. First, I want to find all of the matches, and then I'm going to print out match, and then I'm going to replace. So here's the new one. I have this function called sub, and I have a pattern, and I have a substitution, and I have sentence. So for anything that matches the pattern, I'm going to use the substitution, and I'm going to replace that in sentence. So if, there's no way to run it here. But the important new part is the sub. So here we have a regular expression challenge where we're basically going to use the sub function to substitute occurrences of pattern with substitution. So substitution is regular space expression. And what we can do is we can go back here and we can look at our pattern, and I'm actually just going to copy all of this over because it's all relevant. And I am going to here, well, do I want to find all? So these are what I need to change. I want to assign the regular expression to variable. I want to use the sub method from the RE package to substitute all occurrences of pattern with substitution. So here's my pattern, and here's my substitution. We've already got that. And then I'm going to do re.sub. Well, let's go back and see what that is. Let's get the syntax. And so I'm going to do re.sub, and I'm going to do pattern, substitution, and search string. And then I want to output to the console, replace results. Let's check it, see what happens. And it passed. So again, my regular expression from the previous example was valid in this example. I wanted to use a substitution to replace anything that was a dash, colon, or an at in the word regular expression with just the word regular space expression. So that's the regular expression challenge. Does anybody have any questions? Okay. So I think you and I are the only ones, Joe. Do you have any questions?
No.
Okay. Well, thank you very much for joining me this evening. I will put this up probably tomorrow. Okay?
Sounds good. Thank you for your time.
Okay, no problem. You have a good evening.
You as well.